Hello guys, so in this video we are going to say this problem, find all k distant indices in an array. So let's see what the problem says is, you are given a zero index integer array nums, that is this nums is given, okay, and two integers key and k. Okay, a k distant integer is an index I of nums, that is any index, particular I index, for which there exists at least one index j, such that difference between the two indices is less than equals to k, and nums j is equals to key. So basically what it is saying is, you are given an array, and in that array at any particular position, suppose I, if at k distance from this on the left or k distance from the right, okay, if this is k distance, if you find any j such that difference of a minus j is k, then we have to actually pick up that particular index I. Okay, and what we have to do is we have to return those pair or those i's in an increasing order. That is what they are saying here. So let's see this particular example, the first one, and we'll see like how does this work. So for 3, k is equals to 1, so that is, if we are at I, we have to see one at the left, one at the right. So only these two, we have to go only one distance here, one distance here. So if we see 3, no need to go to the left, we on the right 4, it is not there. When we come to 4, on the right we have 9, so 1 is included in the answer. If we come to 9, then 9 itself is equals to 9, so we have included 2 as well. When we come to the 1, on the left side we have, that is why 3 included. If we have take 3, 9 is there, so 4 included. If we take 9, then 5 included. If we take 5, then on the left 9 is there, so 6 included. So that is why this 1 2 3 4 5 6, they are returned in an increasing order. Now if you see, the constraint of this particular problem is order of 10 power 3. Okay, it means that if you write an algorithm of n square order, then also this answer will be submitted, or this solution will be submitted. So what I'm going to do is, I'm going to do both order of n as well as order of n solution. Okay, so just wanted to discuss that order of one solution. But before that, let's see what is the order of n square solution. Okay, so let's see. So basically, don't go through the code. This is the order of n solution with the time complexity. Let's see here. So what we are going to do is, we are just going to write an for loop from I till what is the length and I plus plus. And each time what we are going to do is, we are again going to iterate from j less than n and j plus plus. And here what we are going to do is, if we are going to find any value, like suppose I minus j mod is less than equals to k, and array, not array, nums of j equals to k, if that is the case, then we are going to add it. Okay, so but here you can see this can lead to repetition of the number. So what we are going to do is, we are going to use a hash set, add all of them in the set. Okay, add all of the i's in that set, and afterwards what we are going to do, we are simply going to put all this set, all the elements of the set in an array list. We are going to create a new array list, and there we are going to pass the set, and then just sort the list, and then return the list. So this type of thing you can do, but this is an order of n square approach. But here we are going to see an order of n approach. Okay, so let's see. Now, see, the problem is, here we are given that an array is there, and at any index I, we have to just see the k distance on the left and k distance on the right. And if we find any of the number 9, so we have to add that. If we modify this question a bit, what exactly it is saying is, let's say if we have any integer I at any index I, at which the value is 9, which is here key. Okay, the value should be key. Here it is 9, so I have taken 9. So k distance from this and k distance from this, we have to include all the i's in our answer. Okay, if this is our answer list, so we have to include all those i's on the left side of this 9 and on the right side of this 9. So what you can do is you can simply iterate over this, find 9, and on the left side, if you see on like k distance, if you see all the index, just add it. On the right k index, just add it. But again, this is going to be an order of n square solution. So what we can do is we can just maintain an array. So what it will do is, suppose this is I, okay. If we find 9 at that particular position, it means that a k distance from this and k distance on the right, we have to take all. So what we are going to do, at k distance, we are simply going to put 1, and at I plus k plus 1 position, we are simply going to put minus 1. Why I'm doing this? Because suppose what we have is, let's take this example, 3 4 9 1 3 5. Okay, so basically 3 4 9 1 3 9 5. So this is our array that is given, the nums array. And what I'm going to do is I'm going to create another array with a length one more than the current one. Okay, why I'm going to do this? Because I'll just tell you. And k value is 1, key is 9. Okay, so whenever we are going to find 9, so what we are going to do, we are going to iterate through the nums. And if we find the key, that is 9, then at k distance from 9, that is at one distance, I is equals to this, at one distance we are going to put 1, and at 1 plus 1 distance we are going to put minus 1. You will see why I'm doing this 1 and minus 1. So what we are going to do is, now we come here 9. Okay. So if when we come here, what we are going to do, we are going to add 1 to the left one and 1 to the right one. Okay, right plus 1. So what we are going to do, when we add this plus 1 here, this will become 0, and this is equals to minus 1. Okay, because we are doing I minus k is equals to 1. Okay, at this position, and I plus k plus 1, we are doing minus 1. Now if we go through this and do a cumulative sum. So what we can do is, here initially it was 0. So here 0, then 1, then 1 again, then here 1, then again 1, then again 1, then again 1, and here is 0. So now once we have done the cumulative sum, whatever indexes that we have whose values are greater than 0, those we have to pick up, and that will be our answer. Got my point, right? So here it will be 0, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. That will be our answer. And that is what we have got here. So this is just this. So here the time complexity will become order of n, and space complexity will also become order of n. So this way you can reduce the time complexity using the space complexity, okay, using some space. So this is what we have done. We have simply gone through each of the index in nums, and if it is equals to 1, we are finding the left one by doing I minus k. Since I minus k can go out of bound, like less than 0, so that is why 0 is there. And this nums length, see we have created one the array with one length extra. Okay, so here also you see we are doing free left plus plus and free right minus minus. That's it. Now when we come outside this for loop, what we are going to do is we are going to see the cumulative sum, and then if the sum is greater than 0, we are just adding it to the answer and returning. No need to sort it, no need to worry about any duplication or anything as such. Okay, so that's it. This is just the problem. Let me try to submit this and see what happens. Okay, it is pending. Yeah, the code got submitted, and here it is. So basically, if you see this 312, I have used that set one. Okay, after that I realized we can do it by using the space complexity as well. So that way you can you can optimize this particular solution, and you can move ahead with this. Okay, so the code, this particular code, you can find the link of this code in the video's description. So go ahead and check that. And if you have liked this video, do comment and like and subscribe to the channel. Thank you.